Hey guys, my name is Scott McGill. I know that these theories may not be popular, but I was asked to analyze and think up my own way to describe gravity and my understanding of it, and I just wanted to share that with you guys. So moving right along, I've got surface tension we'll go over today, planetary placement, and GraviBuoyant theory. Fun word that I put together. So definition that I came up with gravity is an object that has a resultant gravibuoyant vector in any direction. This attraction can be measured externally only when the object is up against the surface tension, like you standing on a scale and it reading a number, or through measuring acceleration if you're free to do so, if you can get an accelerometer inside the object. And to me, gravity, positive and negative buoyancy are all one and the same. And once you kind of break down everything and looking at it as just energy density, and that's the only way you look at anything, it makes a lot more sense. So one thing that I realized that I needed to do to help me calculate numbers better is I updated the gravitational constant to 6.67 to the negative 15 power. So what this means by doing this is now that you can look at the mass of the Earth and the mass of yourself and go through the gravitational constant, and once you convert it to pounds, you can literally calculate your weight that will be calculated on the scale. So it's your resultant vector of gravitational force. So I like the fact that now it can correlate to what's on the scale. And this makes a lot more sense to me than those guys just kind of making up a number back in the day. But I kind of see their train of thought on how they got their number. It's total force. I like resultant force. Moving right along. So it'll help when you see the next slide where it's visualized. But since I believe buoyant forces and gravitational forces are one and the same, I call it gravibuoyant. The resultant vector, you need to go in 3 dimensions. So buoyancy is only known as up and down. Gravity is really known as up and down, or attraction between two masses, but that's not the full picture. The full picture is in 3 dimensions, the X, Y, and the Z axis. So the way to calculate this is to look at gravitational equation between M1, M2, and M3, and then you do it to M4, M2, M5, and then also M6, M2, M7. And then once you calculate that, you subtract the energy density of the medium times the volume of the object times the little g, and that'll give you an equation where you're not only calculating the gravitational force, but it also puts in perspective the medium you're in, because it's not always like it is in the books where you just have a massive object and then nothing in between the 2 objects, and then you have another massive object. Even in space, there's plasma, there's density, there's different energies, and on top of it, it's 2 different worlds when they should be the same. Because if let's say I'm in the magma portion under the mantle, I'm going to have a gravitational pull toward the center, in quotations gravitational pull. I still think it's intermolecular forces. And then you also have buoyant forces up. And so to get your net force, you need to calculate both of these things, buoyant forces and gravitational forces. So I don't like the fact that it's 2 different things, and honestly, the more we get into it, I really think that if you're in the middle of space but you just see light from stars, that's still energy you're interacting with. And you being a body of mass, one portion of you closer to that energy is going to be in a different energy gradient than the opposing part. So you have a gravitational pull pulling you toward the energy you're interacting with, which is in the direction of the star, because that's where it's coming from. Because everybody just, they don't quite understand gravity. It's just buoyancy wherever you go. Wherever there's energy, your mass, your energy will always try to find equilibrium because of gradient forces. So take this in. I think there's a better way to write this equation, but I think overall it's on the right track. So here's the equation visualized. So normally when you have the gravitational equation, it's between like mass of M1 and mass of M2. And in reality, you should be able to see all the directions. So to get a true understanding, you can take this all the way down to the atom, all the way up to the galaxies interacting with other galaxies. But this is a way to visualize the equation in 3 dimensions, which gives you a true resultant gravibuoyant vector. So, you can use this for anything. If you're a beach ball on the surface of the water, if you're a helium balloon in the air, you and me, it took me a while to think about, but you and me are just a rock in the pond. Like, we're more molecularly dense than the air around us, so we sink, and we're up against the surface tension of the Earth. And what we see on the scale is because we have a resistance force that we can stand on. Alright, moving right along. And guys, just bear with me. I've only been studying this stuff for like 2 months, maybe, on and off. Again, one of my friends asked me if I could try and solve gravity, so in a couple of weeks I'll think about all this stuff again and see how I can improve upon it. I know it's not a popular opinion, but it's my opinion, so I just wanted to share it with the world. Alright, moving along. Alright, what did I write on the bottom? So Archimedes' principle, I looked this up because I originally started with just the gravitational equation, and then I was like, I need to kind of merge the buoyancy theories and stuff like that. But Archimedes' principle, any object wholly or partially immersed in a fluid is buoyed up by the equal weight of the fluid displaced by the object. And so just to have the counter viewpoint of that, just to kind of help me understand things, is any object, an object, I just look at it as energy. Think of everything in, like Tesla said, energy, vibrations, and whatever else he said. But any object wholly or partially removed from an energy is weighed down by a force equal to the weight of the fluid replaced by the object. So it's really cool to think of it in both perspectives. And gravity, gravibuoyancy, as I see it, is a combination of these 2 principles, and the only way to calculate the true force on an object, since neither buoyancy nor gravity fully explains everything. So you have to combine these 2 concepts, because it's not black and white where you're just in space and there's nothing. I know in our immediate space it's a pure vacuum, but a lot of space is filled with plasma and subatomic particles and stuff like that. There's never nothing going on. If it's a true vacuum, then there's a reason for that, which we'll get into later. So I'll let you read that. You can just pause it and read it yourself. Again, I'll let you read that. Just pause it if you need to. So I like this picture because this is really how I started thinking about everything. If you go back to the Matrix where he just sees all the codes and everything going up the walls, I started just thinking about everything as then just energy density and surface tension layers, and it just made it a lot more sense. Like it seems like the massless energy is trying to find equilibrium, and that's why it's so repelled by the mass. It goes so fast, but if you look at it, every planet, everything's the same, where the center is more dense than the outside, and the only reason we really feel anything is because we're up against the surface tension of the Earth. And after watching a bunch of NASA YouTube videos, I don't understand why the general consensus isn't the Earth is round because of surface tension. And you look at these things where they fly through space and there's just stars everywhere and it's just little spheres. Go outside and throw a bunch of water up in the air and a whole bunch of little spheres form. It's the exact same thing. To me, this is just completely, a no-brainer that this is how it's formed. And so like even this carbon atom, I mean, it's spherical, the carbon atom itself is spherical, and then the standing waves coming off of it are spherical. And if you look at kind of the energy gradients, if I were a mass kind of in one of these circles, a portion of me closer to the atom is going to experience a higher level than further away, which means I'm going to have a gradient pulling me toward the center of the atom. So again, you can read this, just pause it if you do. Read this too. Here's a cluster of atoms, almost spherical. You know, so we see the carbon atom with spherical tendencies. We see this group of atoms with spherical tendencies. It doesn't stop. I mean, this could go up to the size of a sun, 1 billion times the size of our sun, and there'll still be surface tension. So our core is spherical surface tension. A little bit less dense is the area outside the core of the Earth. That's spherical because of surface tension. The mantle is spherical because of surface tension, and the crust and the water is spherical because of surface tension. And our atmosphere, I guarantee it, has some level of surface tension, even though it's not a liquid. At some level, everything kind of behaves like a liquid. So, you know, just my understanding of it. So without question, for me, this is exactly why everything is spherical, because of surface tension. And the exciting about surface tension, you know, let me just get to this sphere ball. I was thinking about it. I'm like, you know what? If you just put some gallium just underneath the surface, it's not going to be gravity that pulls it to the center. It's more molecularly dense. So the intermolecular forces in the water, or whatever liquid you decide to use, it's going to pull the more molecularly dense object toward the center. So it's not gravity. And so if you keep expanding on this, it's like, well, at what point does gravity just exist? And so there's got to be one consistent method for everything. So it's buoyancy. You know, this is three-dimensional buoyancy. But if you look up some more of the NASA videos, they'll put bubbles underneath the surface, and they'll rise up to the surface tension layer. And if you put the heavier object in there, it will sink to the center of the sphere. And that's not gravity, that is intermolecular forces. And we're just on a bigger sphere of water and silica and magma and stuff like that. It's no different. It's no different at all. So moving right along. You know, I'll let you read this by yourself. Just pause it if you need to. You can read this on your own. Read this as well. Keep this video kind of short if I can. So I like this one, since this is such a popular description of gravity. I get what they're trying to do, and I get the fabric of space and time. It's a nice visual, but it doesn't really describe shit. If you put, let's say 5, I put 3 in the example, but let's say you put 5 bowling balls, 5 volleyballs, 5 balloons, and 5 golf balls, but make the volume the exact same on all of them, so make them all the same size, and you put them on the sphere, you're going to notice that the more molecularly dense objects are going to sink toward the middle. The less molecularly dense objects are going to expand to the outside. And so this shows that things are just trying to find equilibrium to their molecular density. And if you're not in a either if you're not in a balanced setting, you're going to move toward equilibrium. And what I mean by balanced setting is if I'm an object of mass and I've got equal gradient forces around me, I'm not really going to move. But if I have, energy that I'm absorbing from one direction, that's the direction I'm going to be moving it to. So I hope that makes sense. And again, I'm kind of learning this as I go. I know this doesn't align with everything that's in the textbooks, but sometimes it's good to have an outside perspective. So This proves that everything has a positive or negative buoyancy due to the object's mass trying to find equilibrium, and that gravity is a product of an object being pushed up against the surface tension of another. And so that is measured gravity in that example. Moving right along, you can read this one on your own. Take the time to read through these slides. I think this will be eye-opening. There's so much red tape in this community. I don't expect anything to come from this, but I enjoy enigmas, and it seems like gravity is just an enigma that people struggle with, and I think it's way too complicated when it's actually extremely simple once you think about it and get past the red tape. Alright, let's moving right along. Alright, there's a picture of the galaxy. And a lot of my understanding, I studied meteorology for a while, and it just seemed like, there's way too many similarities between a galaxy and a hurricane, low and high pressure systems. I know it's different kind of energy, but it's, the concept's basically the same, except it's just a different way of energy transference. So right along. Planetary placement. This makes perfect sense to me that the sun gives off these acoustical waves that are transmitted through the plasma, and we're just stuck in a node. All the planets are. So I was able to calculate off of the atom, the carbon atom, that it was basically the length of the atom versus the wave was 1 to 1.49. And if you look at the planets away from the sun, if you look at their closest distance and calculate it off it, if you include the asteroid belt, it's 1 to 1.56. So it's very, very close. And so if you look at this picture from 1990, you can see these standing waves, and from my best calculations, it's about 0.47 hertz. I did have a picture of these waves coming off the surface of the sun when I was just going through YouTube videos, but I haven't been able to find that video again. So, if you find that'd be awesome. But I don't understand at all why there is no questions that, because the sun is on an axis and the spherical waves coming off of it, that we're not just inside a standing wave coming off the sun. You can see that the sun's energy dissipates over time because there's a termination shock and other things like that. So here's a picture of spherical waves. Clearly to me, this is why we have the swim lanes and the planets have their swim lanes coming off, going around the sun. And the same swim lanes are true inside the atoms, and it's just proportionally scaled up when the mass increases. So this stuff we went over, you can read it if you want. There's the carbon atom and the peaks on the waves again. There's way too many similarities, I think everything is scaled proportionally up, and you get a massive enough object in the center. These waves come off until you run out and you hit the termination shock, and it's just all in ratio. So there's a picture of the termination shock that the plasma radiated by the sun creates, and the planets are aligned on the axis of rotation of the sun. I love this example. Basically, if you think of the sun in the center giving off these waves, it creates these standing waves, and it's just clear as day, especially if you look back at the carbon atom, that these standing waves are true and exist. And this is how we have swim lanes around the sun. And then like our moon rotates within, it's almost right up against the next standing wave. And so that really gives it bumpers to rotate around the Earth, because it doesn't really make any sense with how far away the moon is from the Earth that the Earth's gravitational pull keeps it in line. It's these standing waves that it's rotating around. And if you look at Smarter Every Day, when they do the acoustical levitation, you can see some of these, you'll see the water droplets levitating in the nodes, but then you'll see the spray of water rotating around it. So same concept. So here's a picture of acoustic levitation. Obviously the sun is in 3 dimensions, so to be a spherical wave, but it's also rotating, so just angular calculations and stuff like that provide the plane that the planets all move around. And so this concept's the same with different planets, different moons, different suns, different galaxies. So the galaxy is basically flat because the center, the black hole in the center, whatever you want to call it, is rotating. And so if you just use standard angular mathematics, you can see that it should be on a flattish plane. So summary points: net force is more important than gravity and buoyancy separate. You got to calculate both together because they're both one and the same. Buoyancy, as we know, is not explained enough. We should watch something buoyant on the micro scale and you understand the universe. So what I mean by that is if you see 2 gold atoms get attracted to each other, that is basically buoyancy. And if if it's attached to something with larger mass, then it just the gravitational force isn't so instantaneous. I think there's a better equation to integrate the 2 theories of buoyancy and gravity, but right now we've got to use what we got. I feel like the more I think about it, the closer I'm going to get to it. But once this clicks in your head, I know a lot of people have a lot of book knowledge kind of stuffed into their brains, but once you kind of realize that, if you look at that sphere of water and just build out, and you just get further away from that water, just because you can't see stuff doesn't mean there's not energy in space. It's clear as day that buoyancy and gravity are one and the same. And if you are interacting with any energy from any source, you're going to be attracted to that source. And so it's just that energy interacting on the atomic level, that provides that attraction. And so for me, it seems like gravity is pretty simple to understand. If there's any energy interacting with energy, they are attracted to each other. And so we're not actually attracted to the sun, we're attracted to the energy that is in contact with us, if that makes sense. So this is my version 3. I guess this could be version 4 since I'm making a recording a little bit. I know it's probably boring as hell, but I just want to get my work out there. I run a different business. I don't really focus on astrophysics and stuff like that, but this is just kind of a hobby of mine. And like I said, my friend asked me if I could think about it and come up with my own explanation, so this is it. And here's a happy turtle. So hope you guys have a good day. Bye.